Right now, while you're watching this, a small blue dot sits 4.5 billion kilometers away. It looks peaceful, but it is not. Winds faster than sound, storms wider than Earth. Until 1989, no human eye had ever seen it close. Then, a tiny spacecraft we had launched 12 years earlier finally arrived, and what it sent back changed everything. Decades later, a brand new telescope turned its golden eye toward that blue dot, and even the scientists stopped and stared. This is the hidden story of Neptune. Welcome back to Proof, where we uncover the hidden truths of the cosmos. If you are new here, hit subscribe right now, because what you're about to hear, most people have never been told. Drop a comment and tell me where you are watching from. I read everyone. Let's start with the part that always catches people off guard. The distance. Neptune is roughly 4.5 billion kilometers from Earth. That number sounds almost polite until you try to feel it. Light, the fastest thing in the universe, takes more than 4 hours to cover that gap. A car driving at highway speed, hour after hour, with no stops, no sleep, no food, would take roughly 5,000 years to arrive. You would have had to start the trip before the ancient Egyptians ever built the first pyramid, and you still would not be there when your great-great-great-great-grandchild climbed out of the driver's seat. That is how far away this world is. And until recently, that is how unknown it was. But Neptune is not just far. Neptune is large. Its equatorial diameter stretches to about 50,000 kilometers. Earth, the planet that feels immeasurably big when you stand on its surface, is only about 12,700 kilometers wide. So Neptune is roughly 4 times wider than Earth. And in mass, the difference is even more dramatic. Neptune is about 17 times more massive than our home planet. If you stacked 17 Earths on a cosmic scale, they would just barely balance one Neptune. And yet, despite being so massive and so far from the Sun, Neptune rotates faster than Earth does. A day on Neptune, one full spin on its axis, takes only about 16 hours compared to our 24. That is a planet turning itself around faster than we do, while being 17 times heavier. But here is where the math flips. A year on Neptune, one full trip around the Sun, takes about 165 Earth years. If you were born on Neptune and tried to celebrate your first birthday by Neptunian standards, you would need to outlive every human being who has ever lived. You would not turn one until you were 165 years old by Earth's clocks. And because Neptune is tilted on its axis, it has seasons, just like Earth does. Except the seasons do not last 3 months. Each individual season on Neptune lasts more than 40 Earth years. Imagine a winter that began before your parents were born and still has not ended by the time you were in your 40s. That is one season on Neptune. And since we have been watching the planet in detail for a few decades now, scientists have actually been able to see these seasons tick by. Cloud patterns shift. Atmospheric brightness changes. We are watching, in real time, a season on another world. We are just watching it on a much slower clock. Now, here's the part of the story most people never hear. How did we find Neptune in the first place? Not with a telescope, not by accident, with mathematics. In the early 1800s, astronomers were tracking the planet Uranus very carefully. Uranus had been discovered in 1781, and they were trying to map its path through the sky, but something was wrong. Uranus was not moving the way it should. It was drifting, wobbling, as if something invisible were tugging on it, something massive. Something far beyond Uranus in the dark. 2 mathematicians working independently, a Frenchman named Urbain Le Verrier and an Englishman named John Couch Adams, both did the same calculation. Both said the same astonishing thing. There has to be another planet out there. They predicted where it should be. And in 1846, an astronomer pointed a telescope at the predicted patch of sky, and there it was, Neptune. Not found by accident, not found by a careful sweep, found because the numbers insisted it had to be there. That is one of the greatest triumphs of human reasoning in the history of science. A planet proven to exist by math, before anyone ever laid eyes on it. And once they saw it, the name was obvious. The early observers noticed immediately that this new world was a deep, almost electric blue. It reminded them of the sea, so they named it after Neptune, the Roman god who ruled the oceans. The color fit, the mystery fit, the almost unreachable depth of color fit, that is what they thought they were looking at. A blue marble. A distant blue marble, and that was almost everything they knew about it for the next 143 years. Now here is the part that most people still do not realize about this world. The winds on Neptune are the fastest of any planet in the solar system. Not just fast, catastrophically fast. Recorded speeds have reached roughly 2,100 kilometers per hour. To put that in human terms, the most devastating hurricane winds ever measured on Earth peaked around 350 kilometers per hour. Neptune's winds are about 6 times stronger than that. They are faster than the speed of sound. They are walls of atmosphere moving so fast that a human being, if they could somehow survive the cold and the pressure, would be thrown forward faster than a fighter jet. And this is where the puzzle gets interesting. and where the first real twist of this story hides. Neptune sits so far from the Sun that it receives roughly 900 times less sunlight per square meter than Earth does. Sunlight drives most weather systems. The heat of a star pushes air around, but Neptune barely gets any heat at all from its star, and yet its winds are the strongest in the solar system. So where is that energy coming from? The answer surprised everyone. Neptune radiates more energy out into space than it receives from the Sun. It has its own internal furnace, some kind of leftover heat from when it first formed, more than 4 billion years ago, still slowly smoldering deep inside. That internal heat, working its way up through the strange layers beneath the clouds, is believed to be what drives the most violent wind machine in our solar system. A wind machine powered by ancient heat, not by sunlight. That is not what the textbooks used to say. That is what they say now. And one of the most famous features ever photographed on any planet sits inside that wind machine. When Voyager 2 flew past Neptune in 1989, its cameras captured something extraordinary. A huge, dark spinning storm system in the southern hemisphere of the planet, the size of the entire Earth. An anticyclone spinning in the wrong direction relative to the planet's spin, with wind speeds around its edges that broke every record we had. The scientists named it the Great Dark Spot. And the obvious comparison was to Jupiter's Great Red Spot, that ancient storm that has been raging in Jupiter's atmosphere for at least 350 years. So the early assumption was that the Great Dark Spot was a permanent fixture, a landmark, a feature of Neptune that would be there forever. Then, in the mid-1990s, the Hubble Space Telescope turned its eye toward Neptune, and the Great Dark Spot was gone, just gone. Dissolved back into the surrounding atmosphere, vanished. More dark spots have appeared in other parts of the planet since. They form, they rage, they disappear. Some of them twist, fold, and tear themselves apart. Neptune does not have permanent storms the way Jupiter does. It has storm after storm, each one a temporary, world-sized event. And that is one of the reasons Neptune keeps surprising us, because we never quite know what we are going to see when we look. Now, the temperatures. This is the part where the physics gets almost cruel. At the very tops of the clouds on Neptune, the thermometer reads roughly minus 201 degrees Celsius. That is so cold, the atmosphere itself starts behaving in ways we never see on Earth. Methane condenses. Hydrogen sulfide freezes into thin layers. The chemistry of the air begins to change just because of the cold. But then you dive. And this is where the planet stops being a frozen ball and becomes something stranger. As you push down through the atmosphere, through layers of hydrogen, helium, and methane, and through those bizarre supercritical fluids, the temperature climbs. And climbs. And climbs. By the time you reach what scientists believe is the core of Neptune, the temperature may approach 7,000 degrees Celsius. That is hotter than the surface of the Sun. The core itself is believed to be roughly the size of Earth, a dense, heavy mix of iron, nickel, and rock, buried under thousands of kilometers of super pressurized fluid. So Neptune is a planet that is catastrophically cold at the top and unimaginably hot at the center. A single world with both extremes living inside it at the same time. And that temperature gradient is not a coincidence. It is the engine that drives everything we talked about. The heat leaking up from that ancient core is what powers the winds. Now, before we get to the moment that changed everything, and the moment that changed everything again, there is one more strange thing about Neptune we should walk through. Its rings. Neptune has rings. But they were not obvious for a long time. For decades, astronomers had only thin, indirect evidence of rings around Neptune. Occasional flickers, uncertain detections. There were even years when the data contradicted itself. Part of the problem was that Neptune's rings are not like Saturn's magnificent glowing ribbons of ice. Neptune's rings are sparse, dark, composed mostly of microscopic dust rather than chunks of ice. They are hard to see, even when you know exactly where to point, and they contain something even more puzzling. Sections of the rings are denser than other sections, bright clumps of material that scientists call ring arcs. These arcs do not spread out evenly. They stay clumped, almost as if something invisible is gently herding the dust. The current best guess is that small moons, gravity from tiny nearby satellites, are holding those arcs together, pushing material back into place whenever it drifts outward. So Neptune's rings are not just hard to see, they are gravitationally choreographed. We have an entire ring system behaving like a dance, with hidden partners holding the steps in place. And the moons. Neptune has at least 14 of them that we know of today. The first 2 were known before Voyager 2 arrived. Then Voyager discovered 6 more in a single flyby. Then Hubble found a small one in 2013, and the count may still be incomplete. Some of them might be small, dark, and hiding in the shadows, but the moon that changes the story is Triton. And this is where the second twist of our whole story lives. Triton is the biggest moon of Neptune. about 2,700 kilometers across. A little smaller than our own moon, but still a substantial world. And it does something almost no large moon in the solar system does. It orbits Neptune in the wrong direction. Most large moons orbit in the same direction as their planet spins, because they were born from the same disk of material that built the planet. They are siblings. Triton is not a sibling. Triton is a stranger. It orbits the opposite way around Neptune, a path called a retrograde orbit, and that is one of the strongest clues in astronomy that a moon was not born where it lives. Triton came from somewhere else, and scientists are quite confident about where. From the Kuiper Belt, the vast, cold ring of icy bodies out beyond Neptune's orbit where Pluto also lives. Triton was drifting through that darkness, minding its own business, and Neptune's gravity reached out and caught it, pulled it in, and locked it into orbit. The capture was not gentle. When a planet the size of Neptune grabs a moon as big as Triton, things break. Orbits that used to be tidy fall apart. Other moons that might have been there before get thrown into chaos. They collide, they eject, they shatter. The system is essentially rebuilt. Most planetary scientists think the current collection of small inner moons around Neptune is the leftover wreckage of that ancient rearrangement, battered fragments, pieces of older moons that did not survive the arrival of the new one. But that is not even the strangest part of Triton. When Voyager 2 photographed Triton's surface in 1989, what it found was shocking. The moon is coated in a frozen shell of nitrogen. In places, the surface is strangely smooth, almost young-looking, as if something inside the moon keeps resurfacing it. And across that frozen landscape, Voyager 2 captured something no one expected. Geysers, nitrogen geysers, plumes of frozen nitrogen mixed with dark dust, erupting up through the ice and shooting as high as about 8 kilometers into Triton's thin atmosphere before falling back down and leaving long, dark streaks across the surface. The energy that powers them is not volcanic heat. Triton's interior is not molten that way. Instead, scientists believe the mechanism is sunlight. Weak, distant sunlight, even at Neptune's distance, passes through the surface nitrogen ice, hits darker material beneath, warms it slightly, and sublimates the nitrogen below, building pressure that eventually bursts upward in a plume. So sunlight, the faintest possible kind, drives ice volcanoes on a world so cold the air itself would freeze. And there is one more thing about Triton. Because of that retrograde orbit, and because Neptune's gravity is slowly tugging it inward, scientists have calculated that in roughly 3.5 billion years, Triton will come close enough to Neptune that the tidal forces, just the stretching pull of the planet's gravity, will tear Triton apart. The moon will break into a vast cloud of debris. And that debris, if the calculations are right, will go on to form a new ring system around Neptune. A ring system potentially far more spectacular than the faint one we see today. Triton will not crash into Neptune. Neptune will dismantle Triton, gently, piece by piece, and spread the pieces out into a glowing ring. That is not speculation. That is a calculated future, written into the math of orbits. So, now, here is the moment that changed everything. The first real photographs of Neptune, the first close-up visit by any human spacecraft, Voyager 2. Voyager 2 was launched on August 20th, 1977. NASA designed it as part of a once-in-a-lifetime plan to take advantage of an unusual alignment of the outer planets. The 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, were arranged in a row in such a way that a single spacecraft, flying past each one in turn, could borrow a little gravitational energy from each, gravity assist, we call it, and get flung faster toward the next. 1 probe, 4 planets, 12 years of slow travel through the dark. Voyager 2 flew past Jupiter in 1979, Saturn in 1981, Uranus in 1986. And finally, on August 25th, 1989, after 12 years in space, it reached Neptune, passing within about 4,950 kilometers above Neptune's cloud tops. That is the closest that any human-made object has ever come to Neptune. And in the brief hours of that flyby, as cameras clicked and instruments scanned, Voyager 2 sent back the first real photographs anyone had ever seen of Neptune. What the people on the ground saw when those images came down through the deep space network was breathtaking. A world, an actual world. Not a fuzzy dot, not a smudge. Bands of clouds stretching across the planet. The great dark storm spinning. White streaks, which scientists nicknamed scooters because they zipped around the planet faster than the larger features below them. Wisps of high-altitude methane ice glowing in the faint sunlight. And that color, that impossible blue. Voyager 2 did not just take pictures. It told the truth about Neptune for the first time. It also confirmed Neptune's rings. It imaged them directly. It found ring arcs. It found new moons, including Proteus, which was one of the largest discoveries. And when Voyager 2's cameras were turned toward Triton, they revealed a landscape that no one had predicted. Nitrogen geysers erupting from a frozen shell of ice. And here is the part that always moves me. Voyager 2 did not stop after passing Neptune. It kept going. It kept climbing out of the plane of the planets, upward and outward beyond the orbit of Pluto, beyond the bubble of charged particles that the sun blows round itself, beyond the heliopause, the boundary where our sun's influence ends and true interstellar space begins. Voyager 2 is in interstellar space right now, today, still sending back data to Earth, although the signal now takes more than 17 hours to travel each way at the speed of light. Voyager 2 is one of only 2 human-made objects to have ever left the sun's protective bubble. It has been traveling for nearly half a century, and every bite it sends back is a gift from a generation of engineers who are now retired, or no longer with us. If hidden stories like this are why you come here, hit subscribe now, because we are just getting started. Now, we have Voyager 2, we have Hubble. But then, something new happened, and this is where the story shifts from old history to recently released science. In 2022, the James Webb Space Telescope, the largest and most powerful space telescope ever launched, finished commissioning its instruments and began its science operations. And on September 21st, 2022, Webb turned its golden eye toward Neptune. The Webb image that came back and the follow-up observations that followed gave us something we had not had for more than 30 years. The clearest, sharpest, most detailed view of Neptune's rings ever captured. Why 30 years? Because since Voyager 2's flyby in 1989, no other spacecraft has been close enough to Neptune to see the rings in detail. Hubble could see Neptune's atmosphere well, but its rings were always faint, and the dark dust between the rings was almost impossible to pick out. But Webb sees an infrared light, a kind of light our eyes cannot see, and that is exactly the kind of light where Neptune's rings shine. Methane in Neptune's upper atmosphere absorbs most of the infrared light bouncing off the planet itself, which means Neptune goes almost dark in Webb's eyes. The rings do not. The rings stay bright. So the rings stand out, glowing against a darkened planet, with a clarity that even Voyager could not match. This was not just a pretty picture. This was the first time we could see Neptune's faint, dusty bands around the main rings again, the same kind of bands that Voyager glimpsed for a few hours and then lost. Webb's image showed us, with the kind of detail that lets scientists measure the rings, that they are sharper, dustier, and more structured than we thought, that they are not just uniform circles, they have clumps, gaps, and finer bands inside them. And here's the twist that the headlines almost missed. In the same single Webb frame, 7 of Neptune's 14 known moons were captured. Galatea, Naiad, Thalassa, Despina, Proteus, Larissa, and most striking of all, Triton. Triton, in the Webb image, appeared as a small, brilliant point of light, almost star-like, because its frozen nitrogen surface is extremely reflective in infrared. So for the first time, we did not just see Neptune, we saw the system. Neptune and its rings and its moons, all in one frame, in a clarity Hubble could not deliver in this wavelength. It was, in a quiet but very real sense, like seeing Neptune for the first time all over again. The same way that Voyager 2 in 1989 was the first real photographs of the planet itself, the Webb image in 2022 was the first clean, detailed look at the entire Neptunian system in a generation. And there is one more moon we should not forget, because it is the one that closes the loop on this part of the story. It is called Hippocamp. Hippocamp is Neptune's smallest known moon, only about 34 kilometers across. It was discovered on July 1st, 2013 by astronomer Mark Showalter at the SETI Institute, working with archival Hubble images. He searched through more than 150 old Hubble frames of Neptune, taken over many years, looking for anything that moved. And there, in those archived photos, was a tiny, faint dot, tracing a slow circle around Neptune that no one had noticed before. That is how Hippocamp was found. Not with a brand new image, not with a flyby, with patience, with old images, and with a pair of careful eyes. And in 2019, follow-up Hubble work, announced by the European Space Agency, revealed something even better. Hippocamp is probably a fragment of Proteus, broken off in some ancient impact, like a chip from a much larger stone. So Neptune's smallest moon is a piece of one of its larger moons. The moon system is still rearranging itself, maybe today, maybe slowly, but still. Now let us take a step back and notice what we are really looking at here. We are looking at a hierarchy of seeing, generation after generation of telescopes, generation after generation of spacecraft, each one a little sharper than the one before, each one revealing something that the previous one could not. Galileo recorded Neptune as a dim star in 1612. 18th century mathematicians proved it was a planet on paper. 19th century observers glimpsed a blue dot. 1989 brought Voyager 2's flyby and the first real photographs. The 1990s and early 2000s let Hubble track Neptune's atmosphere across decades of seasons. 2013 gave us Hippocamp from archived images, and 2022 gave us Webb's unprecedented infrared view of Neptune's rings, and 7 of its moons in the same sharp frame. That is what a quarter century of careful, patient, sometimes unglamorous, mostly government-funded astronomy looks like. It is not a single breakthrough. It is not a single hero scientist. It is a chain, each link weaker looking than a Hollywood moment, and together describing a world we did not know existed. And every link in that chain made the next one possible, and that chain has not stopped. There are real proposals, studied seriously by NASA and its partners, for a future Neptune orbiter. Not a flyby this time. An orbiter, a spacecraft that would arrive at Neptune, fire its engines, and settle into orbit, becoming a permanent companion to that blue world. It would map the rings. It would fly through the strange region of the magnetosphere. It would drop probes into the atmosphere. It would study Triton up close, search for an ocean deep beneath the nitrogen ice. It would take years to plan, years to build, more than a decade to fly there. But the science it would return is the kind of science that would change textbooks everywhere. And there is one final dimension to this story that no list of facts can quite capture. Neptune cannot be seen with the naked eye, not by anyone, ever. If you step outside on the darkest, clearest night of your life and look up, you can see Mercury, Venus, Mars, Jupiter, Saturn, and even distant Uranus under the right conditions. But Neptune is invisible, too far, too dim, too small in the sky. You need a telescope just to see it as a tiny bluish dot. And yet this invisible world is orbiting the same star as we are. It has been there the whole time, throughout all of human history, through every civilization, through every war, through every generation of children who ever looked up and wondered what was out there. Neptune sat out there in the dark, unknown, unknown, unknown. And then we found it by proving it had to be there. And then we sent a robot to look at it. And the robot sent back pictures of a violent, beautiful, supersonic world of storms and geysers and ancient heat. A world the size of 4 Earths spinning silently in the dark. A world that had always been real, waiting for us to learn how to see it. That invisibility is part of what makes Neptune feel so important to me. It tells us something about how much of the universe is still hidden in plain view. How much is out there that we have not noticed yet, just because we have not built the right kind of eye? How many worlds are real right now, this very minute, that we do not know exist yet? Not because they are hiding, but because we have not learned how to look. And here is one more twist, the quiet one most people never even notice, the one that lives in the details rather than in the headlines. Look at the timeline. In 1612, Galileo pointed a tiny telescope at Neptune and wrote it down as a star. He never knew. 2 centuries later, 2 mathematicians doing arithmetic on paper said a hidden planet had to exist and proved roughly where it would be. 1846, astronomers pointed a telescope at that exact prediction. And there it was. 1989, Voyager 2 flew past it and sent back the first real photographs. 2013, an astronomer sitting at his computer, scrolling through old Hubble images one by one, found a moon we had missed. 2022, a brand new telescope saw its rings sharper than they had ever been seen in over 30 years. 2019, the European Space Agency announced that the smallest moon is probably a chip broken off a bigger one. Every single one of those moments was the same kind of moment. A human being paying close attention to something most of the rest of the world was ignoring, and then discovering that the universe had been quietly waiting to be noticed all along. That is what I want you to feel by the time we reach the end of this story. Not the facts, the pattern. Because the same pattern is happening right now, somewhere in the data being pulled down from Webb, somewhere in the archived Hubble frames still being reanalyzed by patient scientists, somewhere in the numbers from Voyager 2 that are still making their way back to us after decades of travel. Someone, right now, is going to notice something about Neptune that we have not noticed yet. Something small, something quiet, something that will end up on the front page of a science magazine in 2027, or 2029, or 2033, because they looked closely at a piece of the universe that most people had written off as already understood. And when that moment comes, it is going to make me feel the way the Webb Neptune image made the scientists feel, like seeing something familiar for the first time. Like the universe had been holding a small secret in plain view for decades, and finally revealed it because we built the right eye. That is the deepest hidden truth about Neptune. Not the supersonic winds, not the nitrogen geysers, not the captured moon that will someday be disassembled into a ring. The hidden truth is that the universe rewards careful observers, and it does it again and again and again. And we are still learning how to be careful observers. We are still learning how to look. And that is why this story matters. Not because Neptune is the most important planet, but because Neptune is the proof. The proof that if we keep pointing our telescopes at the things we think we already understand, the universe keeps finding new things to tell us. Quiet things, small things, things that change a textbook, things that change what we believe is possible, things that change in tiny but cumulative ways, what we think about where we came from and what we think is out there and what we might find tomorrow. So when people ask me what I think is really out there, this is part of my honest answer. The solar system alone is so much larger and stranger than we admit on the average day. Neptune is sitting at the edge of it, spinning its 16-hour day, sweeping its rings through the faint solar wind, holding onto a captured Kuiper Belt moon that is venting nitrogen into space. And the next layer is even more unknown, the Kuiper Belt beyond, the Oort cloud beyond that. And then the stars. The cosmos is calling. Are we ready to explore? Drop a comment and tell me the one fact about Neptune that surprised you the most. Share this with someone who has ever looked up at the sky and wondered. And as always, thank you for exploring the hidden universe with proof. I will see you in the next one.